Title of my presentation is Attack Detection is IoT Data, which uses a hybrid approach using machine learning, deep learning, and meta-heuristic techniques. Before I start my presentation, you all must be aware of what is Internet of Things. Internet of Things, it is a collection of gadgets that are linked to the internet and capable of communicating with one another, and it is referred to as IoT. These devices can be ordinary household devices like smart doorbell, and they can be advanced professional tools. IoT is widely used in the manufacturing, transportation, and utility industries. It is transforming the way some business operate. IoT has a significant impact on our daily lives and work, as it allows machine to handle physically demanding tasks, automate tedious activities, and enhance health, productivity, and comfort. IoT emerges and develops. Several industries have started using them extensively. For example, in the industries like healthcare, agriculture, home, and for office automation. To link billions of gadgets to the internet, it needs trillions of data points which need to be secured. IoT security is recognized as one of the most significant issues because of its increased attack surface. IoT has advanced quickly over the past 10 years because of its wide range of applications in the modern environment. The rapid development of IoT devices has led to development of newer and advanced techniques to attack IoT devices, which pose a serious threat on security and safety of users of these devices. Now, in our daily lives, we, the users of connected devices, are also frequently required to submit our personal information. Sometimes we need to submit our names, our email addresses, even our house addresses, office addresses, ages, and other social network profiles. Now, hackers can use this knowledge to their advantage, and consequently, privacy concerns pose a hazard to IoT devices. There are main two challenges that have been taken care of while doing this research. The first challenge is difficulty in detecting security threats in real time. And the second challenge is ensuring the integrity of IoT systems, evolving challenges. There are mainly 4 research gaps that has been taken care of, that has been met, and they are dealt with. The existing ML techniques are tailored for IoT security, where they have limited application. Another research gap is difficulty in handling high-dimensional IoT data. Another is difficulty in dealing with noise and irrelevant features. And another research gap that has been identified is lack of comparative evaluations. The points which were discussed in the previous slide has motivated us to research and develop more efficient and accurate intrusion detection systems that can detect and classify attacks in IoT environment using machine learning techniques. Specifically, we have used SVM, random forest, k-nearest neighbors, and MLP. Along with machine learning techniques, I have also used deep learning techniques such as LSTM, RNN, and CNN to discern attacks in IoT data. In order to improve the efficiency and accuracy of attack detection, the proposed approach applies the classification process to the feature selected using various methods. Now, for feature selection, I have used 3 different methods. The first is I have integrated the 2 nature-inspired algorithms, which are genetic algorithm and particle swarm optimization. Another algorithm that I have used for feature selection is modified version of gray wolf optimization. Another algorithm that I have used for feature selection is for whale optimization. Now the aim is to optimize the selection of relevant features, thereby enhancing the overall performance of the classifiers. By harnessing the capabilities of ML and DL techniques and utilizing the nature-inspired optimization algorithms, the feature selection This research contributes to improving the detection of attacks in IoT data, strengthening the security of IoT system against potential threats. The proposed model uses this figure that illustrates the process of detecting attacks. The various steps have been proposed in this process. Our first process is data collection. The second phase of this is data pre-processing. Next phase is model training based on ML and DL. Last phase of this process is evaluation of classification results and apply the optimization algorithms based on proposed meta-heuristic algorithms for improvement. Now, for data collection, the research focuses on 4 specific data sets, namely NSL-KDD, UNSW-NB15, CICIDS-2017, and BOT IoT. Each data set contains diverse network traffic data, including various types of attacks, and serves as the foundation for building and evaluating the intrusion detection systems. In the second phase, where data processing is being done, before model training, the data set undergoes pre-processing to ensure their quality and suitability for the models. Data cleaning techniques are applied to remove any duplicate entries and handle missing values, ensuring the data set's integrity. Feature scaling is employed to normalize the data, bringing all the features to a consistent scale, preventing biases from model training. In the third phase, I have used machine learning as well as data learning. Both of these methods, by learning from the pre-processed data, these ML models are trained to classify network traffic into either normal or malicious activities based on the extracted features from the data sets. In the second phase, I have done model training based on machine learning methods, where the pre-processed data is employed to train data learning models. These deep learning models include LSTM, CNN, and RNN. Deep learning models have the capacity to learn intricate patterns from the data, making them adept at complex intrusion detection tasks. The last phase of this process is model evaluation and optimization. After training the ML and DL models, they undergo evaluation using appropriate performance metrics. These metrics may be accuracy, precision, recall, and F1 score. These evaluation metrics provide insights into the model's effectiveness in detecting normal and malicious activities within the IoT network traffic. Based on the evaluation results, optimization techniques are applied to further enhance the model's performance. These optimization techniques may involve hyperparameter tuning, where the best combination of hyperparameter is selected to improve model performance. Now, additionally, adjustments to the model architecture may be made to optimize its ability to accurately detect attacks. Now, I have used 4 different data sets for my research. The first data set I have used is NSL-KDD data set, and this data set is benchmark for evaluation of IDS algorithms. The NSL-KDD data set contains a comprehensive set of labeled data, which includes both normal traffic and various types of attack traffic. The link is given here in the slide. The next data set I have used for the implementation is UNSW-NB15 data set that includes 9 different types of attack classes that makes it a valuable resource for studying various intrusion scenarios. The third data set I have used is CICIDS-2017 data set. This data set provides both raw packet level data and pre-processed flow level data that caters to the needs of different researchers and approaches. The last data set I have used is BOT IoT data set. This data set is tailored to study botnet activities, specifically in IoT environments. The botnet IoT dataset includes 9 types of botnet attacks. It comprises a total of 50 different types of IoT devices that includes cameras, routers, smart TVs, etc. Now coming to the main research work that focuses on using 3 different meta-heuristic methods that I have modified and use the combination of few nature-inspired algorithm. I have integrated the 2 approaches, which are genetic algorithm and particle swarm optimization. Genetic algorithm and particle swarm optimization are 2 iterative optimization algorithms, which are used to solve complex problems. In each iteration, these algorithms evaluate a population of candidate solution and select the best ones to generate new solutions. GA means genetic algorithm takes inspiration from natural selection, favoring fitter individuals to reproduce and create new solutions. However, it may suffer from premature convergence, where it converges to a suboptimal solution before reaching the best possible solution. On the other hand, the second approach which is being used here is PSO, namely particle swarm optimization, which simulates particles moving toward the best solution found so far. While it is efficient in exploiting local solutions, it may struggle with exploration and may get trapped in local optimum. To address the limitations of both algorithms, GAPSO, which is the approach that I have used for integrating both the nature-inspired algorithm, it is named as GAPSO. This hybrid algorithm combines their strengths, achieving a balance between exploration and exploitation for better optimization results. In this hybrid algorithm, the GA component explores the search space, ensuring diversity in the candidate solutions. This helps prevent premature convergence in the PSO component. Meanwhile, the PSO component exploits the best solutions generated by the GA component, improving its convergence speed. This approach shows promise in enhancing the efficiency and effectiveness of solving various optimization problems. It offers a powerful tool for addressing complex optimization challenges in diverse domains. Coming to the algorithm, there are 5 main steps which are involved in GAPSO algorithm. The first step is initialization, then is PSO update, then is genetic algorithm update, then population update, and the last step of this algorithm is termination. In the initialization phase, we initialize the population of individuals with random binary strings representing the presence or absence of each feature. An iteration counter is set, which is set to a value of 1, and it may achieve maximum value to max ITR. In the second step, which is for PSO update, we initialized a swarm of particles with positions of the current population and random velocities of each particle. Perform fitness evaluation for each particle and then update the velocities and their positions. The third step is genetic algorithm update, where for each offspring individual, crossover and mutation operators are applied with probability, PC, and PM respectively. Then evaluation is being done for the fitness of for each of the offspring generated. Now, in the next step, which is for updating the population, here the parent and offspring individuals are combined to form a population of size 2n, and then n individuals are selected with the highest fitness for the next generation. We check for the value for the iteration counter T in the last termination step. If this condition T, the counter T, reaches its maximum value, which is given as max ITR, if it is met, then this algorithm is ended here, and output of the result is algorithm is given. Otherwise, this increment of the counter is being made by 1, and the steps for PSO update, genetic algorithm update, and population update are being repeated again. Now, these are the few characteristics of GAPSO algorithms. The main characteristics of this algorithm combined approach is enhanced convergence speed, escaping local optima and identifying promising regions, robustness and adaptability, overcoming weaknesses, efficiently navigating solution space, balancing exploration and exploitation, fine-tuning parameters. So these are the different characteristics that have been used by integrating the two genetic nature-inspired algorithm, which are genetic algorithm and particle swarm optimization. The next algorithm that I have used, again, it is a nature-inspired algorithm where I have modified gray wolf optimization algorithm. Now, this gray wolf optimization algorithm takes inspiration from the collaborative behavior of gray wolves in their natural environment, making it highly effective approach for solving various optimization problems, including feature selection in machine learning applications. To further enhance its performance, our dynamic mutation rate has been introduced, aiming to provide faster convergence rates and overall improved algorithm performance. The dynamic mutation rate that we have introduced in this enables the algorithm to adapt to the ongoing search process, making informed decision about prioritizing candidate solutions for evaluation. This adaptability enhances the efficiency and effectiveness of the feature selection procedure, leading to improved performance in IoT attack detection tasks. By simulating the collaborative behavior of gray wolves in nature, this gray wolf optimization algorithm demonstrates remarkable capabilities in selecting the most relevant features from vast data set generated by IoT devices. The introduction of a dynamic mutation rate further refines this optimization process, making it a valuable tool for enhancing the accuracy and efficiency of IoT detection, thus contributing to the overall security of IoT systems. The next slide presents the algorithm, which is used for modified gray wolf optimization. Again, it is there in the 5 steps: initialization, update, crossover, mutation, and last step is termination. In the first step, we initialize the position of gray wolves randomly, each representing a binary string of zeros and ones, indicating the presence or absence of a feature. Again, an iteration counter is set, which is again set to 1, and it reaches its maximum value, max ITR. The next step is for update of WGO, where we evaluate the fitness of each gray wolf in the population, update the alpha, beta, and delta wolf positions, calculate average position of wolves for features selection. Crossover is then applied to positions the gray wolves to keep the best solutions. And next, the mutation is updated by a rate P based on fitness value and iteration number. Apply mutation to the positions of gray wolves with a probability which is defined as P in my algorithm. Last step is termination. Again, we check for the counter T. If it reaches, if it meets the maximum values, which is max ITR, then algorithm is ended and we take the output. Otherwise, again, the timer, which is counter for iteration, is again incremented by 1, and we repeat the above steps of update, crossover, and mutation. The various characteristics that I have found while working with modified gray wolf algorithm are its enhanced exploration, increased exploitation, adaptive mutation rate, faster convergence, retain simplicity, handle binary optimization problems, and it is robust and versatile. The last algorithm, next slide please. The last algorithm that I have used is Whale optimization algorithm. Again, I have modified this algorithm by introducing again a mutation, dynamic mutation rate. Whale optimization algorithm is a powerful meta-heuristic optimization algorithm that finds application in feature selection for IoT detection using machine learning. Inspired by the social behavior of humpback whales, this algorithm has demonstrated its effectiveness in resolving diverse optimization problems. To further, as I have said, to further enhance the efficiency of this algorithm for feature selection in IoT detection, a dynamic mutation rate is incorporated into the algorithm. This dynamic mutation rate determines the likelihood of each feature in a candidate solution being mutated or modified during the optimization process. Unlike a fixed mutation rate, the dynamic mutation rate can adapt and adjust throughout the optimization process based on ongoing search status and fitness of the candidate solutions. This is the last algorithm, which is for modified whale optimization. Again, this is there in the 4 steps: initialization, updation, mutation, and termination. In the first step, which is for initialization, we generated an individuals with random binary strings representing the presence or absence of each feature, initialize positions and velocities of the whales randomly, and then again set a timer, an iteration counter, which is set to a value of 1. Then we performed fitness evaluation for each whale in the population, calculated the distance di for each whale to the global best position, updated the positions and velocities of the whales, and again updated the global best position based on the fitness values of the different whales. Next, we applied mutation operation, where selected whales for the mutation are done on the basis of tournament selection method based on certain criteria. In the paper, I have mentioned the equations for this criteria. Then randomly flipped the value of one or more features in the binary string of the selected whales with the probability PM. Then I terminated this algorithm, where this algorithm is being terminated on checking the value of the counter. If it has reached the maximum value, maximum iteration value, then this algorithm is ended and we get the output, where the output is global best solution. Otherwise, again, the increments are being made to the counter by 1, and we go back to the 3rd step, which is for WOA update, and then mutation is being done again till we reach the max ITR value. These are the different characteristics of modified whale optimization algorithm, which are mutation operation for enhanced exploration, diversification for prevention of premature convergence, increased solution diversity, overcoming binary constraints, balance is done between exploration and exploitation, and faster convergence rate. Here in this slide, you all can see the comparison between the different meta-heuristic features. The first 3 columns represent the standard nature. I request to kindly maintain discipline. Comparison is done between different meta-heuristic approaches. In the first 3 columns, basic standard meta-heuristic algorithms are being implemented, which are particle swarm optimization, gray wolf optimization algorithm, and whale optimization algorithm. In the last 3 columns, as you can see in the slide, move the next slide, please. I have modified these existing nature-inspired algorithms, first by integrating the 2 approaches, genetic algorithm and particle swarm optimization. In the other 2 columns that represent modified gray wolf optimization and modified whale optimization, you can see that out of all, we get the best results when we use GAPSO algorithm, where we use the integrated approach of genetic algorithm and particle swarm optimization. Now coming to the implementation. It's okay. To implement the proposed model and evaluate the performance, that experiments were conducted on NVIDIA DGX A100 server with 5 GB graphics using Python language. The description and the data sheet of the server is available on the links shown on the slide. The experiments has been done in Center of Excellence at Netaji Subhash Institute of Technology. Next slide, please. Now, for implementing this work, I have used different Python libraries. The first library that I have used is for NumPy. NumPy is essential for numerical operation and handling arrays and matrices. It provides efficient numerical computations, which are crucial for optimization algorithms as required in my work. Next library I have used is for skikit-learn. This is a powerful library for machine learning. It provides various tools for data pre-processing, feature selection, and classification tasks. Another library which is being used in the work is DEEP. That stands for Distributed Evolutionary Algorithms in Python. It is a versatile evolutionary computational framework. It is useful for implementing genetic algorithm and their hybridization with other optimization techniques. Another library that I have used is PySwarm. PySwarm, as the name says, it is a Python library for particle swarm optimization algorithm for the implementation of PSO. It enables easy implementation and fine-tuning for PSO-based optimization. Pandas. Pandas is a very famous library for data manipulation and analysis. It allows easy handling of data structures and data frames, which can be helpful in preparing data for feature selection and hence the classification. Another library that is being used for generating graphs is matplotlib. It is used for plotting. It is a plotting library rather. It is useful for visualizing the optimization process, and results allow us to gain insights into the performance of the algorithms that we have modified or integrated. Another library that is being used in the work is SciPy. It is a library for scientific computing. It offers various optimization algorithms and mathematical tools that can be useful in customizing hybrid optimization approaches. The last library, but not the least, which is Seaborn. It is a visualization library built on top of matplotlib. It provides additional functionalities to create informative and attractive plots. In this presentation, I have attached some screenshots of my work. This screenshot is taken for the installation process, where it installs the necessary Python libraries like NumPy, skikit-learn, DEEP, PySwarm, Pandas, Matplotlib, SciPy, and Seaborn. As you can see in the first line of the code, where it says pip install NumPy and all other library names. Next slide. Here in this part of the code, loading of the data set is being made. This code segment loads the data set, attaching the specified column names to the data sets. The data sets are used for training and testing. For intrusion detection is network data. I have used network data as shown in the previous slides, where I have used 4 types of data sets, and they are being loaded using this type of code. In this screenshot, this identifies categorical features in the data set and explores the distribution of service feature. As you can see in the last few lines of the screenshot, the categorical features identified are protocol, type, service, flag, and the service flag feature is further has multiple categories that are evenly distributed. Next slide shows label encoder, which is used from scikit-learn. That is again used to convert categorical features like protocol type, service, and flag into numerical representations. And the resulting encoded values are stored as a 2D NumPy array for further processing and analysis. In this screenshot, one hot encoding, which is 1 of k, is used to transform all categorical features into binary features. The input to this transformer should be a matrix of integers denoting the values taken by discrete features. The output will be a sparse matrix where each column corresponds to one possible value of one feature. It is assumed that input features take on values in the range of 0 to some specified number. In the last screenshot, which is code for implementing various meta-heuristic methods, in the few lines of the code, you can see that I have used random forest and then WOA whale optimization algorithm. Then comes the results after implementing my work. This figure shows the results using NSL KDD data set. As can be seen from this figure, it represents precision. Genetic algorithm along with particle swarm optimization exhibits remarkable performance when employed with RNN, as you can see in RNN column where GAPSO exceeds the most. So we say that we get the best results, then GAPSO is implemented using RNN. Next slide, please. This figure represents recall. As can be observed from this figure, RNN achieved the most favorable results when feature selection is performed using, again, genetic algorithm integrated approach where genetic algorithm and particle swarm optimization are combined together. The next figure represents F1 score. As you can again observe from the figure, KNN performs exceptionally well when optimized in conjunction with GAPS. The last result is for accuracy. As again can be depicted from this figure, RNN exhibits the highest performance when utilized with integrated approach of genetic algorithm and particle swarm optimization, outperforming the other models that I have also implemented. Now, talking about the results comparison and their analysis, we can conclude that genetic algorithm with particle swarm optimization exhibit superior performance as compared to modified gray wolf optimization and modified whale optimization algorithm. GAPSO can handle a high dimensional search space. It is effective in finding non-linear relationship between features, and WGO and whale optimization algorithm, where we have introduced dynamic mutation rates. This may require more iterations to converge to optimal solutions. So concluding my work, where we can conclude that in this conducted research, GAPSO modified gray wolf optimization and whale optimization algorithm are applied for feature selection in the area of IoT security using data sets. GAPSO outperformed modified gray wolf optimization and modified whale optimization algorithm and other traditional meta-heuristic algorithm, which are standard algorithm being used like without any modification when they are integrated with machine learning and deep learning algorithm on the selected features. For the future scope of this work, here, this work only detects for different attacks. The prevention of the attack is still left for future as a future scope. So we can say that there is a potential for implementing preventive measures against attacks detected using proposed model. So here we can use this model for detection of the attack and for what should be done in the network once the attacks are being detected. This can further be taken as the future work where the prevention of the attacks can be done using any type of simulator like NS2, NS3, OpNet or MATLAB itself. So there are various different simulators available where we can prevent the attacks. If they are occurring in the network, this can be detected using the real-time data generated using simulator. So you can see the other future work where the generating real-time data set for testing and evaluating the proposed model can provide insights into its practical application. Here I have taken the already existing data sets. Another future scope of the work is we can generate our own data sets where we can use a test bed, where we can use actual experimentation, where the actual IoT devices are being used and the data can be generated through them, data traffic can be generated, and then this traffic can be fed into our algorithm to give us whether whether this network is under attack or it is safe. If it is under attack, again, further prevention measures can be taken to avoid such type of attacks, such type of intrusions in the net. These are the different references I have used in the work. Thank you.
Thank you, ma'am, for your presentation.
Objective functions I have not included in my presentation because of short of time. These are there, all objective functions, all equations related to the work are there in my research work. No, different objective functions. For all different algorithms, objective functions are being modified. There is not a large difference between machine learning and if I talk about the main work emphasize on working on meta-heuristic techniques, I have not just used the different machine learning and data learning models as they are comparative in their results. For this, I have made a change in the feature selection step where I have introduced different meta-heuristic algorithm. And again, they are not used as it is. They are being modified and then implemented.